Preservation planning is essential if you want to ensure that you're doing the right things to your digital objects. We know what the problems are. We know that there are tools out there. We want to make sure we pick the correct tool, the best tool given our constraints. We need to make sure that the evidence that we produce is repeatable. It's a solid process. It's not ad hoc. We do something, figure out this is the best solution, let's deploy it. This is not what a trusted repository can do. So we have a very simple workflow that we'll be showing to you that allows you to plan it and then to deploy the optimal solution that's consistent with the various international standards and initiatives. And you'll be learning about a tool that kind of guides you through the process. So this is the end of the introduction. I've been doing a lot of talking.
To preserve the intellectual capital of my university. There, the data is being stored eventually in the bit, this thing. There is a provision for CNRI handles, which is a type of digital object identifier. And I can do it in an internal identifier also. So isn't that a type of preservation which would help me do it? Do I still need a different preservation plan?
I guess you will need a different preservation plan, because what that software allows you to do is the first level of preservation, the physical bits.
Yeah.
It doesn't migrate them to different formats. So if you have, for example, let's pick a Word document or a PDF document in your archive.
Right.
DSpace stores that object for you. It keeps redundant copies if you configure it in all different ways. That's beautiful. But if then 20 years down the road, Adobe Acrobat is no longer around.
But they say they store it, I mean, I haven't done that, but if like there is a CNRI handle associated, if I take that application, then I'm given an identifier for which it will be preserved. I mean, that is what it says.
The identifier points to the object.
Yes, the identifier points.
You still have the object.
Okay, but you
How
don't
do you
know.
open it?
Okay.
That's the two levels. So it does take care of the bit preservation.
Right.
If you then do preservation planning and re-ingest it, then it allows you also to do the logical planning. Sorry, you have it in the same archive, but you need to decide which migration or which emulation you want to use. If it's a viewer, you point to that viewer and add that information to the object. If you want to migrate it, you need to decide which migration you want to pick. Now, whether it's you who is doing the planning or whether some other institution is doing the planning for you, recommending you a migration strategy, that's a different issue. Here we're learning the basic process, and you can then deploy that or you can outsource that. We'll be discussing that kind of outsourcing as well at the end of today's tutorial. There was another question over there. The previous slide, sure. I'll go back and you just say stop. Conclusions. This one.
So the bullet point concretization of OAIS model there. Could you kindly elaborate on that?
Yes, the OAIS model currently, it's an abstract reference model, and preservation planning is basically those 4 boxes that I've been showing you. Okay? It says monitor technology, monitor community, and then there is this one box which says define a preservation strategy. And what we do is we go into that one and make that a bit more concrete. How do you do that? What do you need to consider in order to come up with a solution? It's basically taking that level of abstractness that any reference model must have out of it and making it a bit more concrete in order to be able to deploy it. We will also show you some of the concretizations for monitoring.
Okay. The second part of it is the plateau. Does it conform to this OAS model, sir? The plateau which you mentioned just now.
Yes, so there is 2 answers to that question. Both are yes. One is a cynical yes, one is a serious yes.
Okay.
The cynical yes means everything conforms to OAS if I take it as an abstract system, because OAS is a very abstract reference model. And even my text editor doesn't do anything that contradicts with the OAS model. It's just not fulfilling it. The serious answer is yes, it does, because the steps involved and the terminology and the connections map to the OS model, and we have a slide that shows you the process of the preservation planning
Fine.
in this whole overview.
Okay. The last one questions relating to that emulation you said, emulation.
Emulation?
Emulation.
Yeah.
This emulation part of it, you said, is it only to retain the legacy information of the digital object? Is it only to retain the legacy information of that particular object?
It's in order to keep the object accessible in the way it was when it was created or when it was being put to use. So you can see it as a legacy over time, but again, digital preservation is also interoperability now. So I can use emulators now to view stuff on different systems. Computer games are a very famous example of that, emulators, or mobile phones. You can take a look at how that software looked on a specific mobile phone on a different computer system, on a PC. So again, it's in order to keep the digital objects accessible, viewable, be able to interact with them. Usually you employ emulation more when the behavior of the object is important, like interactivity, dynamics, whereas you use migration on average more when you're talking about static objects.
Thank you.
So, but these are generic principles that we'll take a look at. Any further questions? There's questions back there. Can somebody probably pass on the microphone? Seid her, geht's bei dir?
Professor, you very nicely talked about different aspects of preservation, and during your discussion you mentioned about the emulation of objects. And at that point you mentioned two things. One is that object emulation is advantageous as well as it is having some disadvantage also, and you very categorically mentioned about that it is having some plus points as well as minus points. And what is plus points and what is minus point? In that regard I need more clarification.
For?
In object emulation, or emulating learning objects. In that respect, further you discuss about that gradually digital objects also deteriorates. So we are having right now only two technologies, digital as well as analog. And even if digital technologies is also going to deteriorate, then what is the next?
Okay, so the advantages and disadvantages of emulation. Basically, the advantage is that you don't change the object. And that has a lot to do with authenticity, the concept that you're able to prove that the object is the same as it was. As I said, when you migrate it, basically the digital file looks different afterwards than it was before. So it's hard to prove that what I show you afterwards is the same that I showed you before. In emulation, you keep the objects intact as they are. You don't change the bit stream. And thus you always have the original object, and that obviously you can prove via signatures, hash codes, and so on. That's one of the advantages. As a second advantage is that there is a lot of things that you can hardly ever preserve with migration. Specifically, interactivity is when you come to a simulation, a software program. You can migrate a software program, which basically means encoding it in a different programming language. So porting it from assembler to C, from C to Java. That would be migrating a software program. However, again, proving that the functionality is the same, ensuring that the time behavior is the same, synchronicity is tremendously difficult. In such cases, emulation is usually an easier approach, because you try to emulate the entire software system, the entire hardware system. Again, I say easier, not easy, because ensuring that timing, synchronicity, and so on is really identical is way more difficult to achieve than people tend to admit. So we were working with emulation, for example, also in the mobile phone development area. And we had programs that were running on the emulator, but not on the phone. Fine, because the emulator might be more powerful. We had programs that were running on the phone, but not on the emulator. Okay, that shows us that even providing an emulation environment is not always perfect. So there is ups and downs to that, But if I want to give the original impression of how it was to use frameworks, the little old office environment I was showing you from a competing software company in those days, I cannot do that by migrating the frameworks file to an Excel sheet or to a Word document or to a PDF. The feeling would be different. If I want to show people how it was to use that, I need to emulate at least their operating system to run the software. If I want to show my students how it was to program using VI, I need to run VI. I can try to write a program that behaves and looks like VI, but it's probably difficult. So that's the advantage of emulation in many cases. Again, none of the solutions is perfect. You cannot trade one for the other. They're very, very complementary. And there's very few people. There has been a heated debate in the community, even up to very recently, where the emulators were fighting the migrators, basically. There's very few people left who are not accepting that fact that they're just complementary, preserving different aspects. Does that answer the question? Okay. Please.
I'll ask myself.
Yeah.
But now the playing systems are no longer only the platforms, like a PC or desktop.
Yeah.
They are becoming increasingly browser-centric.
Mm-hmm.
And in that context, do you think the kind of architectures that are needed for digital preservation, how far they are really reaching to preservation requirements?
Challenging question. Again, there's different layers on which you can answer that question. So very precise and very concrete is specifically for web environments. Preserving anything that's out there on the web is about the most challenging digital preservation setting that you can get. Preserving web archives is one of the worst situations because every single file format that exists worldwide is likely to be found somewhere on the web. Even file formats that do not exist are to be found on the web because they have been implemented badly in some solution and you find them on the web now. So you find lots of stuff that does not conform even to the documented standards. So preserving that is very, very challenging because in reality you would have to create a plan for virtually really tens of thousands or hundreds of thousands of digital object formats. The approach that is now being addressed, still mostly in research project for that, is virtualization and viewers for that. So that's an approach where emulation might offer a very good and rather simple solution, at least mid-term. There is other approaches that try to extract the information from the pages, so the content and the visual appearance, and store that, which would conform to a kind of migration approach. So that's specifically for the web infrastructure. On a more generic sense, I guess where we will need to move to in the mid-term future is moving from a project-based preservation approach, where we sit down, plan something for one specific situation, do it, then do it for the next task, to a more infrastructure-like representation. So where we say, okay, the whole process from creating the object already entails preservation considerations. We are discussing that currently, specifically when it comes to preserving, and that was the example that depicts applications that are web-based, because they are very, very hard to preserve. They're not static objects that you can migrate. And that means that we would need to consider the preservation characteristics already at the time of creation. Both for static objects, it does make a difference in which file format you create an object, but specifically for applications where preservation actually should become part of, I'd say, software engineering principles. How do we document dependencies between libraries? How do we make sure that we minimize dependencies? And this also, we hope, will not only be a benefit for preservation for the long-term future, but also be more cost-effective when it comes to software maintenance and evolution. So here we hope we will find a feedback loop. And that will move into a more closed production, preservation, reusage cycle. But again, we are at the very early stages of that, moving from a project-based preservation to an infrastructure-based preservation. There is also people criticizing the OS model for focusing too much on that. Here we produce, then we give it over to the archive, and here the archive has to preserve. People are criticizing the OS model for perpetuating that view. we have to see what it was designed for, and I still think that for the task was designed for, it's good, but it's true that we need some change here.
I felt that it is almost the next generation internet in some sense,
Yeah.
because now you'll be having the semantic metadata frameworks, everything partly embedded. But is there a proper conscious, say, global movement in such standards, the way internet evolved for this kind of information through OKI or open knowledge initiatives or through W3C and others, so that we are moving in the right direction in this case?
It's hard to make predictions, especially when they're about the future. Who said that? I guess we are moving in the right direction, especially the standardization initiatives are moving in the right direction. The question is whether the world will follow. This is where I have my serious doubts. So we have standards that are being worked upon, especially in W3C. We need to make sure that these standards are adopted. And in order to ensure that, we need to communicate the benefits of, let's call it digital preservation, but let's call it interoperability, or let's call it cost savings in software maintenance, to the industry, to the stakeholders. And if we succeed in doing that, then I think the answer would be yes. If we fail in doing that, then we will have just an evolution where standardization goes one way and reality goes somewhere else.
Thank you.
Yeah.
With open source softwares coming up, do you think it will help up in digital preservation?
The answer is yes on the large scale, but not on a dogmatic basis. That means if you have open source software, the functionality is documented and you can later on reproduce it. The file formats, the standards are documented, and you can go and take a look at them and recreate them even 50 years later, which is perfect. There's two downsides to that. Downside number one is the fact that something is open source doesn't mean that you have any feasible means of understanding the source code. There's lots of source code out there that's just bad or not documented at all. And then it's recreating something by analyzing and understanding the source code is very close to digital archaeology. I'm exaggerating a little bit the situation, but just to get the message across. So the fact that something is open source doesn't mean that you will be able to recreate it completely, that you will be able to understand it with reasonable effort. You'll always be able to understand it if you invest heavily in analyzing it. The other downside sometimes is, and I'm again contradicting or causing spurious or furious contradiction by some of my colleagues in the communities, sometimes an open source format might be of higher risk than a proprietary format. And the reason for that is if it's a proprietary format that's used by millions of people around the world, there is such a huge market that if something happens to that format, a lot of companies will spring up trying to provide a solution for that because there is a business model behind it. If you are the only one setting on an open source standard that's being used by you, yourself, and 20 colleagues of you in your lab, and if that format then becomes obsolete after some time, it's you and your 20 colleagues who will need to provide a migration or an emulator for that piece of open source software. So, in general, yes, definitely, open source, open documentation, standardization is a huge step forward in ensuring that we can analyze the digital objects. We don't need to dive into binary encoded data streams in order to figure out what's in there. But it's not a dogmatic answer saying, yes, for a digital archive, you have to go for an open source solution because that's the only way. It is a benefit, but you have to consider the trade-off. And exactly those trade-offs will be the ones that we consider also in our evaluation. To figure out when is a proprietary format probably better than an open source format. It might be the case, but otherwise, yeah.
So open source can be on the side of migration rather than on emulation, right?
I'd say they could work on both sides. I mean, definitely it helps for migrating because you can transcode the code. In emulation, you're trying to, I mean, the question is what is source? When you're emulating something, you're emulating it at a certain level, either on the application level, on the operating system level, or on the hardware level. In all of these three levels, you need to understand what the system is doing that you're trying to emulate. That means you need to have a complete specification of the operating system or an open source software in order to be able to write an emulator for it. The same applies to the hardware level. If you want to emulate any chip configuration, You can try to understand what the chip was doing by looking at it as a black box, but it would be much better if you had open source documentation of the chip's layout, the processor functionalities, the transistors on there, in order to recreate an emulator for the chip. So I would say open source would be helpful on all these layers, also for emulation, but the more obvious application scenario, I agree with you, is migration.
Thank you.
A bit more details on the OS model.
Yes, more.
Very happily so. How many hours?
No, just I require a little bit. Other explanations.
Okay. I'd need a pointer now, but I'll try my best without having a pointer.
Just a.
So basically what you see in the top left box, the kind of pinkish orange box, that's ingest. And when you see that little box, so we basically go back to this box, it's those boxes here that are expanded in the next slide. So ingest is in the top left box there. And what you have there is 5 different boxes. The first box says receive submission. This is a functionality that takes the SIP, the submission information package from the producer, and basically confirms I have received something of you, validates that it's being transferred correctly, so a checksum, for example. Sends it down to a little box that's below that, that's called quality assurance, which verifies that the SIP is conforming to standards, that the file is fine. Sometimes there is also a functionality there that does, for example, checking for viruses. If you ingest something into your archive, you need to decide if there is a virus. So many institutions have a quarantine period there. I ingest, I put it in a quarantine zone, and then a month later or 2 months